This video is designed to accompany lesson 20 in your lab manual, The Skull. And rather than going through all of the individual disarticulated bones, I'm going to emphasize this model here, the fully articulated skull. And we're going to be giving ourselves a tour of these features by looking at different regions and views of the skull rather than, again, just the simple disarticulated bones. But let's start by just going through this entire model as a whole and making sure that we can identify all of these different bones. So there are 8 cranial bones and 14 facial bones. The 8 cranial bones all make contact with the internal cranial cavity that houses the brain. And then the 14 facial bones are primarily on the anterior part of the skull and associated with the different facial features. So our 8 cranial bones are going to be the frontal bone, the 2 parietal bones, a single occipital bone in the posterior part of the skull, 2 temporal bones, a single sphenoid bone, and a single ethmoid bone that we can get a view of here in the superior part of the nasal cavity. The sphenoid bone and the ethmoid bone are going to be much more easily visible when we look inside the cranial cavity, so you'll get a better view of those a little bit later here. Our 14 facial bones, we have 2 zygomatic bones, 2 maxillae, a single mandible, a vomer, 2 inferior nasal conchae, 2 lacrimal bones, 2 nasal bones, and 2 palatine bones, which are a little difficult to distinguish from this perspective, but we'll get a better view of these in a little bit once we take off the mandible. There are 4 major sutures in the skull, and all of these are structurally classified as fibrous sutures and functionally classified as syndesmoses. These sutures don't actually fuse, they don't begin fusing until at least the mid-20s of a person's life, because they do need to continue to grow as the person is becoming larger. First suture I want to point out is the junction between the frontal bone and the 2 parietal bones, and this is the coronal suture. The sagittal suture is the articulation between both of the parietal bones. The lambdoidal suture is the junction between the 2 parietal bones and the occipital bone. This one gets its name because of the shape. It resembles a Greek letter lambda. The squamous suture is a junction between the temporal bone and the parietal bone, and the squamous kind of takes this curved shape to it. The squamous suture can also be referred to as the squamosal suture. The lambdoid suture can be the lambdoidal. Both of those are acceptable terms for those sutures. We're going to start by identifying some of these features and bony markings from the anterior perspective of the skull, beginning superiorly and working our way down to the most inferior part. I want to begin actually with looking at the frontal bone, and I am going to pull out this disarticulated version so you can get a better view of some of these, especially the 2 frontal eminences. So recall that an eminence is a small rounded projection or bump, and you've got one of those on each side. They're difficult to see on the full model because of where the split is to help remove that top superior part of the skull. If we look below that, just above the orbit, we can see 2 small holes, one on each side. Those are the supraorbital foramina, or notches. Sometimes it'll appear as a true foramen, as you can see here on the left side of the bone, and sometimes it'll appear more as a notch, as you can see on this bone's right side. Just superior to those supraorbital foramina is an arch that's called the superciliary arch. Think about what that name actually implies, superciliary. So it's going to be above the hairs. Ciliary, think about cilia being hair-like. So the superciliary arch is about where your eyebrows are going to be. You can even feel that on your own skull. The supraorbital margin is just simply the superior part of the margin of the orbit. So this is the orbit. This is the cavity where we're going to find the eye. And think about the margin as being that outer perimeter, just like you would have the margin of a sheet of paper. And so the supraorbital margin is just the margin that's on the superior part. Again, if we look at this disarticulated bone, we can see how the supraorbital margin is the part that the frontal bone contributes to. Once we move inferior to the orbit, we can see two more foramina, one right here and one on the other side as well. Each one of those is in one of the maxillae, and those are the infraorbital foramina. So supraorbital, infraorbital foramina. Also on the maxillae, we can see the alveolar processes. The alveolar processes are the small projections that the teeth are actually going to articulate with. Recall that this articulation between the tooth and an alveolar process is a fibrous gomphosis, structurally classified as a fibrous gomphosis, which is also a syndesmosis. Hopefully you don't want your teeth moving very much. Down below, if we look at the mandible itself, we can see two more foramina, one foramen on this side and another one on the other side. Those are the mental foramina. One way to remember those foramina is by thinking about the pose you would take if you were thinking really hard and putting your hand on your chin. You'd probably have your fingers on those two foramina. And then the mandibular symphysis is a little projection here right in the middle of the two halves of the mandible. Let's move on to our lateral view of the skull and begin with some of the features we can see in the parietal bone. Just as we saw two frontal eminences, we also have an eminence on each parietal bone. I will admit it's difficult to see this on the bone itself. It's much easier to feel it, which I know unfortunately you can't do in this video, but it's located right here, approximately this region. On the parietal bone, we can also see two lines, both the superior and the inferior temporal lines, and these are going to serve as points of origin for the temporalis muscle. You can actually see these pretty well on this model right here. We can see one of those lines kind of curving across right here, and then another one that is just below that. So those are those arches of the temporal lines. If we look at the temporal bone itself, the temporal bone has a few different components to it. This large flat portion is the squamous portion of the temporal bone, while this small little projection here is the zygomatic part of the temporal bone. You can probably see where that one gets its name. It's because this is the one that is going to be making contact with the zygomatic bone. Several other features are also visible on the temporal bone. We can see this depression right here, which is actually an opening. This is the external acoustic meatus, which is going to be the tunnelway, the passageway that helps conduct sound into the ear itself. On the more inferior part of this bone, we can see two projections. One here that kind of has a little pointed, almost tooth-like shape to it, and one here that's a little bit stubbier and a little more rounded. This is the styloid process of the temporal bone, and this is the mastoid process. Now that I've removed the top part of this model, we can get a better view of the floor of the cranial cavity, including the three cranial fossa. So recall that a fossa is a depression in a bone, and the floor of the cranial cavity contains three of these. There's the anterior cranial fossa that houses the frontal lobes of the cerebral hemispheres, the middle cranial fossa that houses the temporal lobes, and then the cerebellum is going to sit in the posterior cranial fossa. The other thing that probably sticks out to you as you're looking at this floor of the cranial cavity are all of the different holes that are there, all of these different foramina. We're going to walk through all of these and not only identify them by name, but also talk about what travels through there. Most of the time it's going to be a nerve or a blood vessel. And we're going to start anterior and work our way posterior because that's also going to allow us to identify all the holes that the different cranial nerves travel through. While I know cranial nerves aren't addressed specifically until another lesson or two in your lab manual, we're at least going to introduce them now so you can understand and link them better to these holes that they're traveling through. So the anteriormost foramina that we're going to find are the cribriform foramina. And those are actually all of these little holes that you're seeing in this region of the ethmoid bone. So this is part of the ethmoid bone that's called the cribriform plate, and it's got all of those small little holes in it. Let me go ahead and pull up a disarticulated ethmoid bone here, and so you can get that same perspective here. Again, you can see the plates where there's all of the little holes in them. Those are the cribriform plates, and that's where the olfactory bulbs are going to sit, and the olfactory nerves are going to travel through all of those foramina. So cranial nerve number 1, olfactory nerves, those are going to go through those cribriform foramina. And then you have this plate that's sticking up in the middle. That is the crista galli. That little projection, crista galli, literally means rooster's crest. So you can think about the feathers that are sitting on top of a rooster's head. The next foramina that we're going to come to as we continue moving posterior are the optic canals, one on the left and one on the right. I'm going to go ahead and just poke a little pipe cleaner through this foramen, so you can see the hole that it's going through. And I'm going to turn this skull around now, and you can see where that pipe cleaner is coming through. So here on this side, you can see the hole without a pipe cleaner. And if we look at this side now, the pipe cleaner is going through there. That optic canal is where the optic nerve is going to travel through, cranial nerve number 2. Now, if we were to go back, let's turn this around again for a second and look back at that orbit again. And we can see on this side, not only is there the round hole, the optic canal, but then we can see this line that we have here as well. I'm kind of going to poke this pipe cleaner through that one. There we go, it's going through that slit. And if we come back this way, we can now see where that is going. I know it's kind of an awkward angle, but you can at least see the difference between the slit, that is the superior orbital fissure, and then the rounded optic canal. So there on this side of the skull is where you can see that there's that doesn't have the pipe cleaner going through, and you can get an appreciation for its long, thin shape. And then the optic canal is much more rounded. Go ahead, take those out now. The superior orbital fissure is obviously much larger than the optic canal. It also houses more cranial nerves. It houses the oculomotor nerve, cranial nerve number 3, the trochlear nerve, cranial nerve number 4, the trigeminal nerve ophthalmic branch is cranial nerve number 5-1, and then the abducens nerve, which is cranial nerve number 6. As we continue heading posteriorly, now we're going to get to this little hole right there. That is a little round hole, and it's literally called the foramen rotundum. Think about rotundum means round. The rotunda inside, for example, a Capitol building is a big round dome. So rotundum literally means round. Just posterior to that is where we're going to find this hole that you can see has much more of an oval structure than a round one. Again, we can see it over here as well. That is the foramen ovale. There are 2 more branches of the trigeminal nerves that are going to travel through those 2 foramina. The foramen rotundum is going to receive the maxillary branch of the trigeminal nerve, so cranial nerve 5-2. And then the foramen ovale is going to have the mandibular branch of the trigeminal nerve, cranial nerve 5-3, travel through that. Just beyond that foramen ovale, you're going to see another little very tiny hole. That is the foramen spinosum. You don't have to worry about what travels through that, but if it helps you to remember that feature, think about how thin and tiny a porcupine spine would be, and that would just fit through that tiny little hole. Next comes the foramen lacerum, and the foramen lacerum is this kind of odd structure or irregular shaped hole that we can see just medial to the foramen ovale. So hopefully you've picked up on the fact that the foramen lacerum, spinosum, ovale, and rotundum are all present here in the middle cranial fossa. Now we're going to start moving into the ones that are found in the posterior cranial fossa. Now in between those two, something I didn't mention earlier was you can see this kind of triangular structure here. It looks kind of like a little raised projection that's separating the 2 fossa. This is the petrous ridge. Think about the ridge of a mountain. The petrous ridge is what houses the structures of the inner ear. So right underneath here is where we're going to find the inner ear. And that should make sense to you because recall, I'm going to turn the skull to the side to get that lateral view. Remember this structure right here? This was the external acoustic meatus. Pretend that we could drill a hole right through there. What would we be getting into then? This entire petrous ridge where all of those inner ear structures are going to be. Well, now we also need to get that sound sensory information from the ear to the brain. Let's move back over to this side here. And you can see coming out of that petrous ridge, there's another little hole right there. That is the internal acoustic meatus. So that is going to house the facial nerve, which is cranial nerve number 7, and the vestibulocochlear nerve, which is cranial nerve number 8. And that 8th cranial nerve is the one that's going to be bringing the sensory information both for hearing and equilibrium and balance. Next, in this posterior cranial cavity, if we head just beyond that petrous ridge, you can see this structure right there. Do you notice how it has kind of a little curved shape? If you tilt it just right, it kind of looks like the letter J. That is the jugular foramen. That not only has the jugular vein going through it, but also the glossopharyngeal nerve, cranial nerve number 9, the vagus nerve, cranial nerve number 10, and the accessory nerve, cranial nerve number 11. Right in the middle here, we can see the foramen magnum, and this is the hole that the spinal cord itself is going to travel through. On either side of this foramen, we are also going to be able to see the hypoglossal canal, which is the hole that the hypoglossal nerve, cranial nerve number 12, travels through. You can't see it very well on this model, but when we look at a sagittal cut of the skull, we'll be able to get a better view of that. So just hang on to that thought for a little bit and we'll see that again. So next, let's move on to see what features we can identify on the inferior side of the skull. We're going to begin up at the anterior part by looking at the two maxillae. So we've got here, this is the right maxillae and here's the left one. And if I pull this up a little bit closer, you can see this suture line that's in between two of them. This little mark right here with the gray, please ignore that. That's not actually a hole, that's where a screw is. That helps to connect the mandible when it's attached, but I've taken that off temporarily for you to see it a little bit easier. This hole, however, right there, that is an actual foramen that we're going to find right at the junction of these two bones, and that is the incisive foramen. If it helps to remember that one, think about the incisors as being your two front teeth, and so the incisive foramen is going to be located right between those. Now, if you look at this very carefully, you're going to notice a suture right here, and that is separating the two palatine bones from the two maxillae. You can only see just a very small portion of them, but they're actually a little bit larger. They're more L-shaped. So this is the right palatine bone. So this would be the equivalent of the one that is right there. But as you can see, there's much more to it than the portion that you can see from the external part of the skull. These are referred to as the horizontal plates of the palatine bone. And then if we're back to looking at the maxillae, these flat portions that make contact with the palatine bone are the two palatine processes of the maxillae. I do briefly want to show you the disarticulated maxilla as well. This is a left maxilla, so you can see here where the teeth would be. This is the perspective we were looking at before. And you can see this flat portion right here. This is that palatine process of the maxilla. Together, the palatine processes and the two horizontal plates of the palatine bones are what make up the hard palate of the roof of your mouth. That is one of the three composite structures that we're going to identify here. So remember that one. We're going to come back to the other two in a little bit. Right in between the two palatine bones that's kind of going into the nasal cavity is the vomer, and it's a little difficult to tell that this is a separate bone. You can see so more in the illustrations in your textbook that are color coding them, but if we were to actually look at that bone disarticulated, this is what that bone would look like. The part that you are seeing on the skull is essentially this curve right there. So this portion right there is that curve there. So this vomer would sit in like that. The vomer is also visible from that anterior side. If you recall that we looked at it before, let me come on back here for a second. Here's the rest of that vomer, and you can see how there's this V shape to this structure in the middle. This is the bony nasal septum. This is a composite structure that is made up of the vomer and then part of the ethmoid bone, what's called the perpendicular plate of the ethmoid bone. And together those make up the bony nasal septum. So that's composite structure number 2. Let me just quickly pull up a bony nasal septum here. So this is the anterior view of this. If we were looking directly into this cavity, we would be looking at it like this. And so if I were to tip this to the side, you would see that this is the vomer. Here is the suture line between the vomer and the perpendicular plate of the ethmoid bone. And then this is actually part of the sphenoid bone, and this is the sphenoidal sinus, which we'll get back to the sinuses in a little bit. This V shape that you see right here in this septum is the same as that V shape that you can see right here in this model. So this is the anterior view of the vomer, but from this perspective we were just examining, you can also see the posterior view of the vomer. So while this is the vomer, if we go over to here, these are actually parts on either side of the sphenoid bone. So we're on a completely different bone here at this point. I'm putting the picture up in the corner again of that inferior view of the skull, the illustration from your textbook. And the pictures that you see there in purple, that is this bone, while you can see how the vomer is in yellow. So that's kind of distinguishing between those. These are referred to as the pterygoid plates of the sphenoid bone. And this is the complete sphenoid bone. This bone is probably the most difficult to appreciate the shape of just by looking at the completely articulated skull. The view that we are looking at as we are looking at the inferior view of the skull is pretty much this perspective right here. So these projections that are sticking out right here, this one that's medial and then this one that's lateral, are these projections here. This one is the medial one and this is the lateral one. So it has a slightly different shape. They're not quite as symmetrical with each other as you can see here, but those are referred to as the pterygoid plates. Pteryx is Latin for wing. Think about a pterodactyl, for example. And so on each side we have a medial and a lateral pterygoid plate, and as a whole those make up what we call the pterygoid process. Let's move on to some structures that we can see on the temporal bone that we've previously identified, but we can get even a better perspective looking at it from this inferior view. So remember, here's our temporal bone, and we said that two of the processes we can see projecting on this inferior side are this rounded one and this pointy one. And hopefully you remember that this pointy one is the styloid process of the temporal bone, and this is the mastoid process. Right in between those two on the lateral side of the skull is where we're going to find that external acoustic meatus, recall. And then just anterior to that is going to be this little divot right here. That is the mandibular fossa, and as you can probably guess based on the name, that is where the mandible is going to articulate with the temporal bone. In between the styloid process and the mastoid process, you should be able to see one additional foramen. That is the stylomastoid foramen. The stylomastoid foramen serves as a passageway for the facial nerve, cranial nerve number 7. We've already mentioned that cranial nerve once because it passed through the internal acoustic meatus, but as you can see in this image, which is actually from one of our charts in the room, the facial nerve actually passes through two foramina, not only through the internal acoustic meatus, but then after going past the inner ear region, it is going to curve inferiorly and travel out through the stylomastoid foramen. Ultimately, that facial nerve is going to be transmitting sensory information from the anterior 2/3 of the tongue, and also transmitting motor impulses to some muscles that are associated with facial expression. From this view of the skull, I also wanted to point out that I've already put this one pipe cleaner through, but I can point out the other one on the other side right here is the carotid canal. And as you might be able to guess based on the name, there's one of the carotid arteries that's going to travel through here, and specifically it is the internal carotid artery, which is one of the major arteries that supplies oxygenated blood to the brain. If we want to see where that comes out in the cranial cavity, I'm going to turn this on over, and you can see where my pipe cleaner is coming through on the other side. It's actually going through this hole right there, which you can see kind of on that just anterior to the petrous ridge, but also just lateral to the foramen lacerum. Before, we were looking at the cranial floor from this perspective, so that's why we couldn't see the carotid canal, we couldn't see the opening for it. But if we turn this around now for this perspective, we can get a better view of where that's going to be visible. The last thing that I want to note from this inferior view of the skull is this giant arch that you can see right here, one on either side. That is the zygomatic arch, which is the third composite structure that we're going to talk about in the skull. This is the zygomatic bone, and this is the temporal bone. This portion right here of the temporal bone that makes up the zygomatic arch is the zygomatic process of the temporal bone. This small little projection of the zygomatic bone that contributes to the arch is the temporal process of the zygomatic bone. Zygomatic process of the temporal bone, temporal process of the zygomatic bone. Together, those make up the zygomatic arch. While we've already talked about the sphenoid bone a few times, I did want to point out a couple other features of it, both on the disarticulated bone and on our partially open skull. If we were to look at this from a superior and a posterior perspective, we would be looking at this bone as it would sit here in the skull, as it would sit here articulated with the rest of the skull. So this little depression that is right here is equivalent to this depression right there. And this is called the sella turcica, which literally means Turkish saddle. And this is where we're going to find the pituitary gland. So the pituitary gland is going to sit in the sella turcica, and that's where it's going to be protected. In addition, we can see what are referred to as the wings of the sphenoid bone. The sphenoid bone has lesser wings that you can see are kind of these smaller projections right here, and then the greater wings as well. If we look into here at the articulated skull, those lesser wings are going to form kind of one of the most posterior parts of the anterior cavity, while the greater wings are going to be down here and contribute to that middle cranial fossa. Excuse me, I meant anterior cranial fossa. It's the anterior cranial fossa and the middle cranial fossa. I'd like to revisit the ethmoid bone for a minute to point out a few additional features. We've already looked at this superior surface to see the two cribriform plates as well as the crista galli, and we were also able to see that on in the anterior cranial fossa. In addition, we looked at the ethmoid bone through the nasal cavity, and we're able to see the perpendicular plate, and then those two other projections, which are the middle nasal conchae. If I were looking at it from that same perspective, again, here you can see the perpendicular plate and then the two middle nasal conchae. But you can see how the ethmoid bone has other structures to it as well. These two structures that are on the sides of it, on the most lateral portions, are referred to as the lateral masses. And those contain what's known as the ethmoidal labyrinth. This contains the paranasal sinuses of the ethmoid bone. And we'll again revisit those paranasal sinuses at the end of this video. But I wanted to point that out because you can only see those on this disarticulated bone. The last complete bone that we have to review is the mandible. So the mandible is one single bone, and we've already mentioned a few components to it. You recall that we have the two mental foramina and then the mandibular symphysis that's found in the middle. And then if we look at the main portion of it from here all the way around, kind of this anterior curved portion, is what we refer to as the body of the mandible. While these two projections that project both both superiorly and posteriorly are the rami. Singular of that is the ramus. At the end of the ramus, you'll see how it splits into two different projections. This one right here is the condylar process, or the mandibular condyle, and this is the part that is going to articulate with the mandibular fossa of the temporal bone to create the temporomandibular joint. And then this point right here, this pointier one, is the coronoid process. Please do not confuse that with the previous coronoid process that we've talked about on the ulna. This is the coronoid process of the mandible, and it serves as an attachment site for the insertion of the temporalis muscle. Just as we had alveolar processes on the maxilla, we also have alveolar processes on the mandible. And then if we turn this around to this posterior view, there is a small little projection right here that this screw is actually going into, and that is the genoid tubercle. This serves as a point for some muscle attachments, but it's a little difficult to see on this model because there happens to be a screw in it. This mid-sagittal view of the skull gives us the opportunity to see some features that weren't visible from any of the other perspectives we've looked at thus far, and the most notable of which are probably the paranasal sinuses. So the paranasal sinuses are centered on the nasal cavity, and they have a variety of functions. They help to lighten the weight of the head. They help to heat and humidify the inhaled air. They increase the resonance of speech, which is why your voice tends to be affected when you are congested and there's fluid filling those sinuses. And they also can serve as a zone to help protect the vital structures of the face in the case of some kind of trauma that hits it. So there are 4 paranasal sinuses. The first of which here is the frontal paranasal sinus that's located in the frontal bone. The maxillary paranasal sinus, which we did see a little bit of on the disarticulated maxilla. The sphenoidal paranasal sinus, which we didn't get a chance to see before because it's located within that sphenoid bone. And then there were the ethmoidal paranasal sinuses, those air cells that are located in the lateral masses of the ethmoid bone. In addition, one of the other features I mentioned we were going to have to wait on this view to see is the last foramen that a cranial nerve travels through, and that is this one right here. You can see from that kind of strange angle why we weren't able to get a good view of it from that inferior perspective of the view of the cranial floor, and that is the hypoglossal canal. So that is the hole that the hypoglossal nerve, cranial nerve number 12, is going to travel through. While it isn't officially classified as a skull bone, I did want to acknowledge the hyoid bone that lies just inferior to the skull. This is actually the only bone in the body that does not articulate with any other bone. Instead, it's actually suspended by several ligaments and also serves as an attachment point for some muscles that move the tongue and the larynx. And finally, we're going to examine some of the structures that are unique to a fetal skull that you won't find on an adult skull. Now, as birth is approaching, the brain is growing very rapidly, and essentially the bones of the skull are not able to keep pace, even though they are also growing. And so at birth, you're going to find areas of fibrous connective tissue that is in between the cranial bones. Now, those connections are very flexible, and that allows the skull to be distorted during birth as it's passing through the birth canal without causing any damage to the skull. There are several large areas of this fibrous connective tissue that are casually referred to as the baby's soft spots, if you've heard of those before, but they're officially known as fontanelles. This one right here that is between the frontal bone and the parietal bones is the anterior fontanelle, also known as the frontal fontanelle. In the posterior region between the 2 parietal bones and the occipital bone is the posterior fontanelle, also known as the occipital fontanelle. And then on either side of the skull, we have a fontanelle that's in between the frontal bone, the parietal bone, and the temporal bone and the sphenoid, and that's referred to as the sphenoidal fontanelle. There's one on each side. And then just posterior to the temporal bone is another one, that's our last one, and that's the mastoidal fontanelle. The mastoidal fontanelle is also referred to as the posterolateral fontanelle, and the sphenoidal fontanelle is also called the anterolateral fontanelle. So all of those fontanelles have multiple names to them, and you are fine using either one of those. A couple other features that you might notice on this skull: the two frontal eminences are much more prominent on the fetal skull than they are on the adult skull, as well as the parietal eminences that you can see on either side. In addition, you might have noticed that the frontal bone has a suture down the middle of it. This is called the metopic suture, and that's because the two halves of the frontal bone don't fuse into a single frontal bone until after birth. You can also see on this specific model here how the two halves of the mandible haven't fused yet either. And so once that does fuse, this is where that mandibular symphysis would be located.